All right, so we're going to talk about square root functions today. So we're going to read through a bit of this, and then we'll look at a problem and how to, visually do it. So to graph a square root function, we'll review the idea of real solutions to square root functions. In order to have a real solution, they must be greater than 0. Otherwise, we would have to use I, which represents imaginary numbers. That's when we have a negative sign under a square root. Because remember, that's not actually possible, right? Because a square root is a number that was multiplied by itself to get there. So, if we say that, 9 is a square, well, I can do 3 times 3 to get to 9, or I can do negative 3 times negative 3 to get to 9. Either one results in a positive, not a negative. So if I have a negative under the square root sign, it's imaginary. So that it just says that, we're not taking into account I in our answers to account for negative square roots. So here's an example using 25 instead of 9. So now on this one, I have x minus 2 under the square root sign. So this needs to be 0 or positive. So x minus 2 has to be greater than or equal to 0. So x must be greater than or equal to 2. So this will be the leftmost point of the graph and is also the domain of the function. So there's definitely a limit there. I can't go below 2 because 2 minus 2 gets me 0, and it has to be greater than or equal to 0. Okay, so all square root functions have a basic shape like the one shown to the left, where they have a point where they're starting and they're swooping to the side. To graph on ALEKS.com program, we need the leftmost point. That is where we're practicing what we were just practicing above here, and 3 more points. Using perfect squares, you can make graphing simpler, although it is not required because there is a coordinate plotting tool where you can definitely plot some decimals there. But if you get whole numbers, much, much easier to graph, so you don't have to worry about any rounding. Oops, we'll talk about that in a moment. So that just popped up there. So we have graph the function 2x plus 2. So we have that same idea it's very similar to the problem we were just looking at. Instead of x minus 2, now we're looking at x plus 2. So remember, same deal. That has to be greater than or equal to 0. So in this case, if it has to be negative 2. So it must be greater than or equal to negative 2. And I can simply just subtract 2 from both sides as well to just solve that inequality. So my leftmost point is going to be negative 2, 0. Okay, so there's my leftmost point, negative 2, 0. And now I need 3 more points. So I'm going to get perfect squares. I'm going to look at this and just say, how do I get perfect square? So to get 1, I would have negative 1 plus 2, right? I'm adding 2 to that, and I'd get 1. So my first number that I'm going to plug in is negative 1. To get 4, I'd have 2 plus 2. And then to get 9, I'd have 7 plus 2. So I'm going to plug in negative 1, 2, and 7. So I'm kind of forcing that perfect square idea. Again, you don't have to do that, but it does make it a little easier to graph. So I have negative 1, 2, and 7. So you can see on the side here, I filled in the x coordinate already. I'm going to go through and I'm going to plug them in really quick and see what I get. So I have negative 1 plus 2, and I get 1 here. So the square root of 1 is 1. And then I'm going to plug in 2. 2 plus 2 is 4. So the square root of 4 is 2. And then I'm going to plug in 7. 7 plus 2 is 9. And the square root of 9 is 3. So you can see that made it much easier to graph these 3 points because they were just nice, easy numbers to graph. Now, if you do get decimals, you can do that. If it's a repeating decimal, then sometimes ALEKS gives you grief about rounding. That's the only reason I'm pushing the perfect square root idea. So this is graphing a root function. I hope that helped, and I will see you in the next video.